Welcome to this explainer. Today, we are going to engineer the perfect DNA of an exam answer. I like to call this the geneticist approach to the Cambridge computer science exams because if you want an A-star, it all comes down to a very specific formula. Evidence plus analysis equals success. We're diving deep into why Cambridge principal examiners consistently report that processing arrayed data, specifically the bubble sort algorithm in the 9618 syllabus, is one of the most brutally misunderstood areas in the entire subject. To show you exactly what the grading room is looking for, I want you to imagine two students tackling a real, high-stakes Cambridge computer science past paper question. Let's call them Alex and Sam. Now, Alex is the kind of student who overloads every single answer with raw computer science facts, writing huge paragraphs, but entirely misses the actual analysis. Then you have Sam. Sam rushes the paper, completely misses the command word requirements, and drops massive points on technicalities. Throughout this explainer, we are going to look at their flawed answers, see the red pen marks they get from examiners, and completely transform their approach.
Look at the core disconnect we have right here. Why do students, just like Alex and Sam, find interpreting complex binary representations or visualizing array shifts so incredibly difficult when the exam clock is ticking? It usually comes down to memorizing textbook definitions without actually understanding the mechanics underneath. Alex will sit there and just data dump everything they know about arrays, while Sam will ignore the specific scenario entirely. It's like having all the parts of a car engine scattered on a garage floor, but having absolutely no idea how to put them together so the car actually runs. But we are going to fix that right now. We're taking an exclusive under-the-hood look at the examiner's grading criteria. We are going to turn those raw, disjointed facts into high-scoring, tightly structured analysis that examiners literally cannot ignore.
Here is our roadmap to completely mastering array data. We'll start with core principles, move into algorithmic methodology, reveal the all-important method mark strategy, highlight the top examiner warnings, and cap it off with critical analysis and evaluation. Let's jump in.
Starting with Section 1, Core Principles and Building the Theoretical Architecture. We absolutely must start with the theoretical foundation. The assessment objectives for computer science target three distinct cognitive domains: knowledge, application, and analysis. Notice the massive gap between passing and excelling here. On the left, you've got our average student. This is Alex. Alex has a superficial breadth of knowledge, just regurgitating raw facts about loops and arrays without answering the actual prompt. But look at the right side. The top-performing candidate shows a connected, conceptual understanding that transfers seamlessly to entirely unfamiliar contexts. This is where we introduce the Peel framework: point, evidence, explanation, and link. Top students structure every single one of their computer science answers using Peel to ensure they hit the command words perfectly. Examiners don't want a brain dump. They want logical, structured reasoning. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
The crucial point here is that your knowledge of causal relationships has to integrate with other areas of the Cambridge syllabus. This applies whether you're studying 0417, 0478, 0983, 0984, 2210, or 9618. When you explain how a bubble sort swaps adjacent elements, you can't just state the basic mechanics and stop there. That's what Sam does, and Sam loses points. Principal examiner reports explicitly highlight that candidates who reference cross-topic connections, like how the sorting process directly impacts memory management or program efficiency, achieve significantly higher marks. This is the link part of the Peel framework. You make your point, you provide the evidence from the algorithm, you explain the mechanics, and then you link it to the broader system impact. It's all about showing the examiner that you understand the bigger picture.
Let's move into Section 2, Algorithmic Methodology and the Procedural Framework.
You simply cannot bypass algorithmic thinking. It is the absolute engine driving your success when processing array data. As defined here, algorithmic thinking requires step-by-step decomposition, selecting the appropriate data structures, ensuring efficient code implementation, and applying rigorous testing. But before you can do any of that, you have to decode the command words in the question. Are they asking you to describe, explain, or evaluate? If the command word is evaluate and you just describe the bubble sort, your grade is tanking. This is exactly where Sam rushes and misses the entire point of the question. You need to be able to seamlessly transition from decoding the command word to designing the algorithm to implementing and testing the solution.
This right here is what we call the computer science success blueprint. Whenever you tackle past paper questions, I want you to follow this exact standardized sequence. Step 1, deconstruct the question and extract the relevant data. This is your command word decoding. Step 2, select your analytical framework, meaning get your Peel structure ready. Step 3, execute your logic with clear, precise notation. And Step 4, present your final answer using the correct terminology. Let's do a live transformation. Imagine Alex wrote a messy, unstructured paragraph about array sorting. If we take our red pen, cross out the fluff, and force Alex to use these 4 steps, we instantly see red marks turn into green check marks. We strip away the unnecessary facts and replace them with targeted step-by-step logic. If you follow this procedural framework every single time, you are practically handing the examiner exactly what they want to see on a silver platter.
Let's dive into Section 3, the Method Mark Strategy. This is your ultimate safety net in the exam.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGC to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGC and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, look closely at this examiner alert. It is massive. Students consistently lose marks by not showing their working. When you are tracing a complex bubble sort, it is so incredibly easy to make one tiny indexing error and misplace a value in your final sorted array. But here is the secret. Even if your final answer at the very bottom of the page is completely wrong, method marks can absolutely save your grade. Never, ever leave your process blank. To practice this, let's do a quick interactive workshop. Challenge number 1, data scan. I'm going to put a complex 60-second timer on the clock in your mind right now. Imagine a massive, complex data array on the screen in front of you. Your job is to extract the core trend before the clock runs out. Do you see how the larger numbers are bubbling to the top? If you only write down the final sorted array and mess up one number, you get 0. But if you document each swap, pass by pass, executing your analysis with clear systematic working, that is exactly what captures those critical method marks step by step.
Moving on to Section 4, the top 3 examiner warnings. These are the critical mistakes you have to avoid.
You need to memorize these 3 specific mistakes straight from the principal examiner reports so you do not repeat them. First, students confuse cause and effect in the algorithm. They completely fail to explain why a specific pass triggers a specific array state. Second, they forget to check boundary conditions and edge cases. Ask yourself, what happens if the array is already sorted? What if it's completely reversed? And third, providing generic textbook answers that are not specific to the context given in the question. This brings us to challenge number 2 of our workshop, find the flaw. If I show you a sample paragraph that says, a bubble sort uses a nested loop to check every item, which takes a long time, what is the flaw? The flaw is that it violates warning number 3. It provides a generic answer with no specific context, and it fails to explain the boundary conditions. Always tie your logic back to the exact scenario provided in the prompt, or you're just throwing points away like our friend Sam.
So how do we fix this? Here's a great memory hack to overcome those exact pitfalls. Creating a quick mnemonic using the first letters of key terms is a highly effective way to trigger your memory for boundary conditions during a high-pressure exam situation. Find a phrase to remember steps like compare, swap, pass, flag. This ensures you never miss any edge cases when the clock is ticking down. Let's jump into challenge 3, speed writing. You have 30 seconds. I want you to write one perfect PEL paragraph in your head right now using that mnemonic. Point, the algorithm flags a pass. Evidence, no swaps occurred. Explanation, the boundary condition of an already sorted array was met. Link, this improves efficiency by preventing unnecessary loops. Foam, that is how you engineer a perfect answer. Build your mnemonic and write it at the top of your scratch paper the second the exam begins.
Finally, we reach Section 5, Critical Analysis and Evaluation. This is all about mastering higher-order objectives.
Higher-order assessment objectives demand that you don't just mechanically execute an algorithm, but that you evaluate it critically. This deconstruct, solve, evaluate loop is your blueprint for achieving that. Identify the given information, break it into logical steps, solve systematically, check for reasonableness, and finally, make justified recommendations. This ties into the 3 ultimate rules that guarantee top marks. Rule 1 is command word decoding, which we've covered. Rule 2 is Peel framework application, ensuring your logic is bulletproof. And Rule 3 is the time management matrix. If the examiner asks if a bubble sort is the best choice for a massive data set, you can't spend 20 minutes writing a novel about it. You need a structured, timed way to evaluate that choice, make your recommendation, and move on to the next question. To truly master evaluation, you must analyze trade-offs and acknowledge limitations when comparing algorithmic approaches. Let's look at this table. For alternative solutions, you must evaluate and compare different approaches directly against one another. Don't just look at bubble sort in a vacuum. Compare it to an insertion sort or a linear search, depending on the context. Next, analyze the trade-offs. Sure, a bubble sort is incredibly simple to code and great for small datasets. but you must analyze its severe performance limitations on large datasets. That's the nuance the examiner wants. Finally, justification. You must support your final decisions with concrete evidence pulled directly from the exam prompt. If the prompt says the array has 10,000 elements, use that number in your justification to explain why bubble sort is highly inefficient.
Let's lock in our 3 key takeaways from this system. First, ensure you connect concepts across topics to prove deep conceptual understanding. Second, always show your workings so you secure those vital method marks. Don't let a tiny math error ruin your grade. And third, rely on the deconstruct, solve, evaluate loop to hit those higher-order objectives. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. You have to be designing algorithms, implementing solutions, testing thoroughly, and most importantly, practicing these PL techniques on actual past paper questions so you don't end up like Alex or Sam.
I want to leave you with this provocation. If you had to evaluate your current exam strategy right now, where are your weakest boundary conditions? Are you rushing the contextual application, or maybe dropping method marks by trying to do all the array shifts in your head? Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.